Steps 12 in class exercise 7 relative motion analysis. Two planes A and B are flying at the same altitude. If their velocities are VA equal to 500 km per hour and VB 700 km per hour such that the angle between their straight line course is 60 degrees, determine the velocity of plane B with respect to plane A. So we are calculating VB with respect to VA. This is what we need to determine. And they both are the velocities of both the planes are given as shown in the figure. So step number 1 is we set up the coordinate system. So the better point to set up the coordinate system for each plane and write down the equation for the velocity of both the planes. So we set up the coordinates, we define the coordinate system as going right positive, so which is for x-axis, and unit vector for that is I, and if it's going up then it's positive y, and unit vector for that axis is j. So unit vector defines the direction for I and j respectively. So we set up that coordinate system for plane A, so it's x, y or ij, and we do that same for plane B. X, y or rj, and we write down each one of this velocity as a Cartesian vector. For example, VA can be written as Cartesian vector. It does not have any x component because it's moving only in y direction, but in negative y direction. So this can be written as minus 500 j, and the speed is in kilometer per hour. VB, on the other hand, can be written as this V, that is 700 at this direction, and this angle is 60 degrees. So we can write, when we apply cosine of this angle, so V cosine 60 will, VB cosine 60 gives us the vertical component, because this is the arrow, this is the angle 60 degrees, so this is VB cosine 60, that will point in the positive direction and open the angle. So when you take cosine, it closes the angle between these two lines, and when you take sine, it will open the angle and it will give us the VB sine 60 as the x component of the velocity. So write down that here, and they both are positive. This is positive x and this is positive y for this coordinate system. So this is VB sine 60 I plus VB cosine 60 j. Okay, and the value of VB is 700, which is given. So you substitute that 700, multiply with this, and get the final answer as 606.21 I plus 850 j. And this is kilometers per hour VB. Okay, so now the last step is to calculate velocity of B relative to A, which is nothing but vector B minus vector A. So it's 606 minus 0 because there is no I component. So this is 606.21 I, but then it's 850 minus 500, so that will become plus 500. Oh, sorry, there is a mistake here. So this is not 850, this is actually 350. So yeah, it's 350 minus 500, so that is 350 plus 500, and that is 850 j. Okay, and that's V as a vector, and now VB relative to A as a vector. We need to calculate the magnitude of this vector, which is square root of x component plus y component square, and that is 1044.02 kilometers per hour, and angle theta, which is tan inverse 850 divided by 606, which is 54.5 degrees. And that's our final answer.